Example 3 says find the terminal point of these angles. Part A gives us the angle theta equals 5 pi. Now, to make things a little bit easier on myself, I'm going to use the concept of coterminal angles. So we know that one full rotation around the circle is equal to 2 pi. So if I subtract off 2 pi, that leaves me with 3 pi, and I can subtract off another 2 pi, and that will leave me with pi. And so 5 pi and pi are coterminal angles, and pi is a little bit easier to work with. I know that pi is half of the circle, so that's going to end me up right here if I draw that. And we want to find the coordinates of that point that I've highlighted here. And the coordinates are going to be -1, 0. Okay, part B gives us the angle theta equals pi over 4. If we wanted to convert that to degrees, remember, we'd take pi over 4 and we would multiply it by 180 over pi, 180 degrees over pi. The pi's would cancel out, and I have 180 degrees divided by 4, which is equal to 45 degrees. Either way, our angle is going to be in quadrant 1, and it's going to be right here. And this is one of those special angles that we graphed earlier, and the terminal point that's associated with this angle is the square root of 2, 2 over the square root of 2, 2. So that's our answer for part B. Part C, we are given the angle theta equals -4 pi. And here, similarly, I can use the concept of coterminal angles. So I can add 2 pi to it, and then I can add another 2 pi to it, and that's going to give me 0. So -4 pi and 0 are coterminal angles, and both of those are right here, and that coordinate, or that ordered pair rather, is 1, 0. Next, we're going to be talking about reference angles. Let theta be an angle in standard position. The reference angle associated with theta is the acute angle formed by the terminal side of theta and the x-axis. And recall, acute angle means that the angle is between 0 degrees and 90 degrees, or if we're talking about radians, it's between 0 and pi over 2 radians. So it's useful to know the quadrant in which the terminal side of the angle lies. Let's draw the reference angle for each of these 4 examples. The first graph has theta in quadrant 1, and so the reference angle here is actually just theta itself because it already forms that acute angle with the x-axis. I'm going to label the reference angles since we already have theta. Why don't I label the reference angle alpha? So in this next graph, the reference angle is going to be this angle here, and I'll call that alpha there. In the next graph, the third graph, the reference angle is going to be this angle here, alpha, and then in the last graph, the reference angle will be this angle here. Example 4 says, find the reference angle for the following angles, then the terminal point of each angle. So the first one we are looking at is theta equals 4 pi over 3. And like I said earlier, I think it's helpful to first determine what quadrant the angle is in. So I've labeled my y-axis and my x-axis, and I know that 3 pi over 3 is the same as pi, and pi we know is on the negative part of the x-axis right here. So in order to get 4 pi over 3, we're taking pi and we are adding pi over 3 to that, and that ends up giving us 4 pi over 3. So if we have drawn the unit circle here, then 4 pi over 3 is going to be in quadrant 3, and it's going to be somewhere like approximately here. And so again, to reiterate, I know that this length is pi here. I've highlighted that in red, but the reference angle is this angle here, the acute angle that's formed by the terminal side and the x-axis, and that angle is pi over 3. So for part A, the reference angle is pi over 3, and then we want to figure out the coordinates of the terminal point here, and whatever it is, we know that it's going to be negative and negative here. What might help us is, since our reference angle is pi over 3, and when we were dealing with the special right triangles earlier, we were dealing with degrees, so why don't we convert pi over 3 into degrees? So if I do that, 180 degrees divided by 3 gives us 60 degrees. So we can say that the reference angle is pi over 3 or 60 degrees. Okay, let's return to that unit circle that we drew to see if we can figure out what these coordinates are. Okay, so we're back here, and I'm going to extend the black line down here. And since this here is 60 degrees, that's going to tell us that this here is also 60 degrees, and that was the reference angle for that last example that we were looking at. And so I'm going to highlight the terminal point right here, and we know that it's going to be negative something, comma, negative something, and I'm just going to basically take the terminal point that we have here, and I'm going to make the x value and the y value negative to figure out what this point is. So this would be negative 1/2, comma, negative root 3 over 2. So that basically has helped us answer the question that we were just looking at. And so to reiterate, this is going to be negative 1/2, and this is going to be negative root 3 over 2. And so that is the terminal point for 4 pi over 3. All right, let's do part B now. So we're given theta is equal to 855 degrees. That's a large angle. And so again, I'm going to work with coterminal angles. So if I did 2 revolutions around the circle, that would be 720 degrees. So I'm going to subtract off 720 degrees, and that's going to be 135 degrees. So let's figure out where that is on the unit circle. I know that this here is 90 degrees, and this here is 180 degrees, and so 135 degrees is going to be somewhere in quadrant 2. So this is 135 degrees. And I knew to draw it there because the reference angle here to complete that half rotation of the circle is going to be 45 degrees. So the reference angle is 45 degrees, or if we were to write that in radians, that is pi over 4. And so if I draw my little right triangle there, we want to figure out the coordinates for that terminal point. And we've already dealt with using that special 45-degree right triangle. And if I reflected it into the first quadrant, we've already solved this right triangle, and we know that the coordinates for this is root 2 over 2, comma, root 2 over 2, but we want to find it for the reflection over the y-axis. And so the terminal point, if we reflect it over the y-axis, is going to be, they're going to have the same y value, but the x value is going to be negative since it's in quadrant 2. And that completes this example.